That's what you are concerned with. The whole other stuff doesn't really concern you. Then I gave three cases that if adventure you were solving, if adventure you were solving, and the answer of x here equals the answer of y, the principle was here. See, A here, the answer of x my numerator, B here is the answer of x my denominator. So there are three cases. Is one, if they are equal to each other, then the entire limit is simplified to only extracting the coefficient of those powers. I get my point now. Now, if A is greater than B, the whole limit simplifies to and if A is lesser than B, the whole limit simplifies to what? Zero. Shall I get my point, please? Alright.
I'm fine. At infinity.
Everything I'm doing here is at infinity. Shall I get my point? Okay. Let's look at some other cases.
Abeg o.
I'm not sure
It's just blow.
the these ones.
Nobody wants to leave their phone for too long. Àwọn tó ń rojọ́ ìlú dùn nínú Ọlọ́run.
Ọmọ ẹ̀rọ ìlú ìlú
Azal. Àwọn fún sábọ̀ ní ti gbìyànjú straight. Lẹ́yìn ìsìnkà. And impact focused into the 2-1 tutorial. True. This is the first full page I've written since the beginning of this semester.
So now let's start.
Apart from
So I gave some other different forms too. Like I said, I'll just be going straight to the points, give you everything you have to learn, and let's see how far you go. Now in cases like this, now here, you observe that if I plug in my infinity here, everything gives us that limit. The way for me to evaluate this is to rationalize.
Yes.
Multiply up and down by the conjugate of the solid by numerator. Which means that this just means that saying limit number 3. Where we're going to say let's go with the let's go with the next. One time. Go with x
Let me recover.
plus x.
Banana snapping is now.
Another stuff we have to do.
They play.
Now, the difference of two squared, remember, like it's like
I won't put that
this
on
square
channel.
e minus b e plus b. So by close
By
observation,
Gabriel.
you can realize that the numerator is mimicking the element of two squared. Yes or no? Yes. Where this your square root here is your a, and your x is your what? Is your b. So without having to expand, let's just be right. You can be written as limit as x tends to infinity. Square root of x squared plus x whole squared minus x whole squared. Yes or no? Following difference of two squared. Then here, another way to be square root of x squared plus x plus x squared. Now by expanding, I believe everybody's going there now. Let me just put that close to the side. By expanding here, square cancels the square root. We are limit as x tends to infinity. Or what? X squared plus x minus x squared. All over square root of what? X squared plus x plus x. How would you get that? How would you get that? Right. So we have that x squared and cancel x squared here. What if happened? This will give me limits as tends to infinity. Expand, you get this x squared cancel minus x squared. You are left with x only in your numerator. How to fix it? Alright, now from here, let's by that analysis, I will solve it. You don't have time to expand to this event of two. If you compare some people in the whole order of limits, for you to evaluate limit as x tends to infinity, you are supposed to divide the denominator and numerator by the highest power of x in the denominator. So I can't divide 2 by x squared here. If I want to do this denominator, I will have to divide 2 here by x cubed. And doing x cubed, I will have something over x in my numerator. Something over x also be my numerator. And don't forget, anything divided by infinity give us 0. So that's why this one here will always give 0 back. Question 5. If we continue this pace, shall I not be parting from other version? So please right back. All end of there, 6s minus 1 all over square root of 9x squared plus x. Now, first thing I can tell you in this case is I'll repeat it back here. So factoring that out, I would have limit as x tends to infinity. I would have it to be 6x minus 1 all over x squared 9 plus 1 over x. Factoring out x squared in my sort here. I will get at this.
Yes, sir.
Then for that, limit as x tends to infinity.
And the cost person.
6x minus 1. Don't forget to split it. Square root of x squared.
Square root of 9
plus 1 over x.
X.
Then it will give you limit and x tends to infinity. 6x minus 1. X square root of 9 plus 1 over x. Now I can divide my everything here by x. So I'm to divide my numerator and my denominator by x so that this x here can move.
Okay.
Doing that, I will end up having
6
limit as x tends to infinity of 6 times 1 over x all over square root of 9 plus 1 over x. Now, I can now confidently plug in my words, my infinity. And I'll give you what? 6 minus 1 over infinity all over square root of 9 plus 1 over infinity. And don't forget I said 1 over infinity is what? 0. So you just have 6 all over square root of 9. And that is 6 over 3. And that is what? That's it.
Láti one or two wà lẹ́wọ̀n àkẹ́.
But the previous job is here in our midst. But the previous job here in our midst. You can probably guess what I will do that next question here. I said yes, except if you are left see. The answer there is 1. Do you believe it? The answer that I want to do that number 6 is 1. How is it 1? Repeat same as here. I don't have to factorize it. I mean, rationalize instead. So after square root of x square root of 1 plus. I want to stay inside. You have your answer.
Yes, sir. Now you just square root, no, square, x over 4 is, square root over 4 is x. No, x over 4 is x. So,
There's no square root in the denominator.
okay.
Second part limits.
Sir? Sir? Crown.
Everybody open the back of your notes. Let's do a short test. Yeah. Let's do a short test. Let's do a short test. 2 divided by 0, write your answer. 2 divided by 0, write your answer. Next one. 4 multiplied by 0, write your answer. 4 multiplied by 0, write your answer. The next one, out there. The next one. 4 multiplied by infinity, write your answer. 4 multiplied by infinity, write your answer. 4 times infinity, write your answer. Are we there? Are we there, please? Infinity divided by 5, write your answer. Infinity divided by 5, write your answer. I hope some people are writing question and answer together. Who is writing question and answer? Because by the time I start calling, so that you tell me, then I tell the answer. Where am I?
Infinity divided by 5.
Infinity divided by 5. The next one, 7 over infinity, write your answer. 7 over infinity, write your answer. Have you done that? The next one, 0 divided by 0, write your answer. Next one, infinity divided by infinity, write your answer. Are we there? The next one, 0 multiplied by infinity. 0 multiplied by infinity. Are we there? Infinity divided by 0. I'm not imagining the answer. Imagine someone just writing 1, 1. They are telling me infinity cancel infinity 1. Okay? Where am I? Where am I? Where am I?
Infinity divided by 0.
Infinity divided by 0.
Infinity divided by 0. Have you written it? Okay. 1 raised to the power of infinity. Write your answer. 1 raised to the power of infinity. Have you written it? 1 raised to the power of infinity. Write it. The next one. Infinity raised to the power 1. No, sorry. It shouldn't be infinity raised to the power 1. Next one should be infinity raised to the power 0. Sorry. Infinity raised to the power 0.
When you go and book me, but you
How many is that? Alright, let's start. Let's start saying the answer. What's question number 1?
0 over 2
Is what?
0.
Okay, that's correct. Next one.
2 over 0.
What's the answer?
0. Zero.
I wrote hello. Let me take 5 minutes of your time, of our lecture time, to catch too small before I continue. I wrote 0 over 0. I mean, that question I just did. What is it?
2 over 0.
I wrote 0. Raise up your hand. Don't lie.
Don't lie.
I wrote 0.
Raise up your hand.
Clap for yourself. We are brilliant students. Now, for time's sake, you can't divide everything by 0. So which means that anything divided by 0 is not infinity. It is undefined. So if you wrote infinity and 0, you are wrong. The answer is what? Undefined. Next one.
You didn't put it there, exhibit.
Yes. Next one.
times 0.
Alpha, yeah.
0.
4. Next one.
4 times infinity.
Any answer?
Infinity.
Okay, let's take that infinity.
Infinity divided by 5.
Eh?
Infinity divided by 5.
Infinity.
Don't know about
Divided
infinity.
by 5 is infinity.
Don't know about infinity.
Is what?
0.
Eh?
0.
Eh?
0.
The answer is 0.
I got it. I swear everything I wrote, I just wrote 0 in everything. I don't know.
Next one.
I don't know the answer. 0.
0. That one. Who say 1?
Divided by 0 is undefined. Next one.
Secondary school group.
Divided by infinity. Again, it's also undefined. Don't say 0 is not 0 and it's not infinity. Next one.
Oh, come Willing Secondary School.
0 times infinity.
0 times infinity is undefined. 0. Undefined.
Undefined.
Next one. Divided by 0. Divided by 0 is what? The next one. What is my infinity?
At the control stuff. At the control
It's
What's it here?
What is my infinity?
I'm using it for the video.
Undefined.
I want to shape it.
The next one.
Can't shape it back.
Infinity raised by 0 is 1. Infinity raised by 0 is 1. Infinity raised by 0 is undefined. Next one. That's all. So what I've said is, I think also, and let me there are like 6 I've started with. There are like 6 indeterminate form. Now, first of those indeterminate form is that something divided by 0 is indeterminate. Asterisk that stuff that I'm saying. Those are indeterminate form. Something divided by 0. What is it now? Something divided by 0 is what?
Okay, I want to
Undefined. The next one that we have is what? What else gave us undefined? That
Hello?
0 divided by 0
0
divided by 0 is an indeterminate form. Asterisk it too.
Just like this being different.
Undefined, yes. All the answers that I gave you as undefined, asterisk them.
0 divided by 0 is undefined.
0 divided by 0 is undefined. Anything divided by 0 is undefined. 0 times infinity is undefined. 1 is for infinity is what? Undefined. Infinity divided by 0, undefined. Infinity multiplied by 0, undefined too. Infinity over infinity is what? Undefined. So all the answers I gave you undefined are what? Are called indeterminate form. Now for the next part of limits that we are entering, anytime we see indeterminate form, we will apply L orbital rule. Yes, write it down. L orbital, that is L apostrophe orbital.
It's Otugbe Debe.
See, SS2, this boy.
All over go me boy.
L orbital rule. L orbital, as I said, L orbital rule, we use this form. We use this form whenever you have what? Indeterminate form.
Where did you draw that?
I'm not drawing now.
I'm not drawing. You can draw go.
Back to what I was saying. Anytime you have indeterminate form, you apply L orbital rule. And And what is the concept of L'Hopital rule? L'Hopital rule is used when we have determinate formulas, as I said, and it's all about differentiating your numerator separately and your denominator what? Separately. All things being equal, because in this thing there's 102. Yes, and for those of you guys that might have attended my class last semester, I taught this thing too. Alright, good. Now for this next section, there are like 40 examples. But I'm not going to do that 40 examples. I will pick anybody at random. And let's see. How many examples did I do in the first part?
12.
I did 7 now. Did 7 or 6? 6. For this next set, I'll call any 7 person at random. Do not overthink it. Pick any number from 1 to 40. That's just it. Don't overthink it. Are we together? Just don't overthink it. Pick a number. How will you get right? Should we start? Yeah. Now, the bro with red, face card black, Nike.
It's on the screen, bro.
We are called, please. Just don't have to call me here. Stay there and call number. Number 1. You call number 1. Okay, no problem. We like big simple ones. I don't want to sabi. Help someone write number 1 down for me, please. Sister with how do I describe? What's the name of this your clothes here? No, that's all of it. They are pink.
Casted.
140. Pick a number. 12. They have every number 12 down. Top brother at the back. You. I think you're the tallest in that back, yes. Don't stress. Just sit down. 35. Write 35 down. Fine work. Pick number, Baba. 11. Write 11 down, please. Just at the black corner. Versas. Yes. 17. Okay. But I don't anyone do me. Pick number.
26.
26. How many is that? 6. One more person. Sister with the color headgear. I don't know. Is it not color? It's color now. Oh yeah, pick number. 140. Don't overthink it. 40 itself. 14. Alright. What's question number 1? So I asked you to pick number at random. So if I did not do some part, I'm supposed to touch. It's not on me. I want to ask you to pick at random. What next number? 12. As x tends to about 5 minus 50 over x. Next number is 5. 35. We are going as x tends to 0 of x minus x minus 1 all over x. Next number 11. 11. Limit as x tends to 4. X cubed minus 64 all over x squared minus 16. Next one.
26.
What's the next number, please? The mark the question is the number 26. And x tends to 0 minus 5 plus x 1 minus 5 minus x. Oh, sorry.
gbé mi débẹ̀.
Yeah, that's not what you're saying.
Give us
I'll give you bonus. I'll give you as last one. Let's start.
Mi ò lè rí ṣe.
So, number one, what to solve this? First thing you have to do is simple. How to get out of this? Now, first in your mind, before you do anything first. So first, provided you are doing limits, first thing I'm doing is that, first of all, plug in that limit inside your X and check if you have an indeterminate value. That's the first thing. Whatever answer, let's do it. Whatever limit you have here, I get my point. In this inside the entire function. If you will have an indeterminate answer, what will you use? L'hopital. But does not have an indeterminate answer, where will you answer like that? Yes, I get my point. Let me go so that it doesn't look like a problem. And number one, we have given as x tends to 2, or what? 5 minus x. We know that if I put 3 there, I cannot have an indeterminate sum. That is just plug in 2. 5 minus 2 should give us 3. Number 2, given as x tends to 2, or x power 5 minus 32 all over x minus 8. First question, look at it. If I plug 2 here, will I have problem or not? Will I have problem or not?
problem. Yes.
Because 2 raised to power 5 is 32. 32 minus 32 my numerator will give me what? 0. 2 raised to power 3 is also what? 8. 8 minus 8 will give me what? What do we do? L'hopital. And what does L'hopital do means? You differentiate your numerator separately, your denominator what? Separately. Limit as x tends to 2. Differentiate this one end up having 5x all over 2. Now from here, you observe that by plugging in my 2 here, I will not have any undetermined form again. Yes or no? Yes or no? So let's plug in 2. 5 times 3 to the power 4 all over 3 times 3 squared. If any I want to do, this is 5 times 16, it will give me 8c. 3 times 4, that's 12. And how many, if you divide, I don't know. 2, I don't use 2, and I use 4. Yes. That will give me 20 over 3. And that's my answer. Sure. You understand? Yes. Number 3. Look at it now. Limit as x tends to 0 of exponential x minus x minus 1 all over x. Observe, if you put 0 there, would there be a problem or not? If you put 0 inside that function, would there be a problem?
There will be.
Are you sure? Yes. There will be a problem because exponential 0 is 1. If you put this one here, all I know about 1 minus 0 minus 1, and that's what? 0 in my numerator. If you plug in 0 here, all I know about my numerator, 0. So I cannot use it like that. What do I have to do? L'hopital. Let's differentiate. Limit as x tends to 0. Differentiate the exponential by exponential x minus what? 1. Minus 1. Then I calculate my numerator. It will be here now. Yes or no? Yes. Then for me, I can have immediately put in your answer. Answer your own level having here. Please do not be scared of 0 is answer. The only thing you are looking from is what? Determinate form. 0 over 0, infinity and infinity, and all of those terminate forms like that. I wish we had been Number 4. Look at this. Limit as x tends to 4, x to the power 3 minus 64 all over what I have x squared minus 60. Observe. Plug in 4 here. Will I have a problem or not? Will I have a problem?
Yes.
Yes, I will, because 4 to the power of 3 is 64. And 64 minus 64 will give me what? 0. 4 to the power of 2 is 16. 16 minus 16 also give me what? 0. So, L'hopital rule. limit as x tends to 4, what I end up having here? Dx squared 1 over 2x. So plug in your 4 now, without having any issue. As 3 times 4 squared, all over 2 times 4.
Okay, as x tends to means x is
3
equals
times
to
now,
0.
3 times
X
16.
is equals to 5.
Why?
I don't know what's this for.
I would say that is. Now let's not do the last three, which you think might be hard, but at the same time it's not hard. Okay. Separately, there is a numerical level and not separately. Now look at number 5. First thing first, as I said, before you do anything, check. If I plug in 4, you have number 5. Will I have a problem with it? Check first. You plug in 4 and have number 5. Will I have a problem?
Yes.
Because, for example, if 4 inside the square becomes 5 plus 4,
Yeah, nine.
that's 9. Square root of 9 is what? 3. Now, if you do the same thing here too, plug in 4. 5 minus 4 is what? 1. Square root of 1 is 1. 1 minus 1 is 1. Which means that this is a typical case where I have to use LHOPITAL rule. Now, I think I can use LHOPITAL rule and at the same time I can factor, what do you call that thing? So, rationalize. But I think differentiating here would be smarter, provided you know how to handle your differentiation without having any issues. And this square root of x a, I can write it now as limits as x tends to what? 4. 3 minus 5 plus x is power what?
1 over 2.
All over 1 minus
5 minus
x is power
1 over 2.
1 over 2. Don't forget power rule. For example, if you have something like this, let me lay down the foundation of what I'm going to differentiate. Suppose you have 4x minus 5. So once you put one number, any number, and 9, 11, 99, 1 number equal 99. So suppose I want to differentiate this. What trick do I use to differentiate? The other power I have on top, I write it out first. 9. Multiply by differentiate what is inside. 4. Multiply by write your question back and you come from your power. 4x minus 5 is power 8. And by the time you multiply it, you will then 6, 4x minus 5 is power 8. So I want to apply this principle to this part. Don't forget about the connecting here. Yes or no? So let's differentiate. By differentiating here, minus 1 over 2 comes to the front. 1 over 2 times differentiate x here.
1
Times 5 plus x. 1 over 2 minus 1 give what? Minus 1 over 2. All over same thing here. Minus 1 over 2. 1 over 2.
minus 1.
Minus 1. That's your question here. 5 minus x. Minus 1 over 2. I would say that this. Then by simplifying your entire numerical here. Simplifying. What do you observe as our by simplification? So this one you're going to limit as x tends to 4. So I have minus 1 over 2. This entire thing here can be written as 1 over square root of 5 plus x. Yes or no?
Actually,
Yes. Right. Same thing here. I have 1 over 2 times 1 over square root of what? 5
minus x.
As a half cancel half. Then you can plug in your limit inside. So what this one giving here? Minus 1 all over 5 plus 4 all over what? 1 all over what? 5 minus 4. Square root of 5 minus 4. Then we know that this one here will give me what? Minus 1 over square root of 9 will give me 3 all over 5 minus 4 is what? 1. And square root of 1 will give me what? 1. 1 over 1 is what? 1. Final answer is what?
Minus 3.
Minus 1 over 3. That's what. I will apply the same property here to question 6. Yes? How did the 3 is a constant, and if you measure the constant, you have 0. Then that disappear.
More Gagi.
I can explain again. And if you realize, plugging in for your give me 0 over 0. So let's just differentiate. But
The
before
fear of
I
God is the
let me
beginning of
write
wisdom.
such a way I can answer. Square root is saying that I something 1 over 2. Then differentiate. 3 and 1 are constant, so they need. I think I have minus here. Say minus here. How am I talking to the front? When I 5 plus x. How am I talking to the front? Exactly. Why is this still here? There's subtract 1 from the power. So that it was half here. By subtracting 1 from half, it became minus half. Same thing happened here. Then just simplify to get the answer. Okay.
Power bank. I cannot see him. What you gonna know? Don't be distracted.
This one here. Yes. How do I get it? If I get minus x. If I get minus x here, I have minus 1 now. That's I got my minus 1. Any other issues? Right. Now looking at question number 6. Applying the error without here will also give me what? Give me a problem. I guess my point is this. So I mean, I said applying error without give me a problem. Plugging in my unit here give me a problem. So let's differentiate. Number 6. If I get it down number 6, what would I have then? Limits as x tends to a. How want to come to the front? 5 over 3 times. Differentiate what you have in your denominator here. 1. Then write your question root 1. X minus 2. Raise to power 5 over 3 minus 1 should give me 2 over 3. Oh, x plus 2, thank you. Now I want to show you. A plus 2 raised to power 5 over 3 is a what? It's a constant. Yes or no now? A is a constant, 2 is a constant. So the entire thing raised to power 5 over 3 is a what? A constant. And if you differentiate the constant, what do you end up having? So there's no need for me to differentiate this. Or you can calculate 0 and everything here divided by differentiate x minus a, what do you end up having here? 1. By the time you plug in your a here, 5 over 3, open bracket, a plus 2 over 3. If I put in a here, I will have problem because it will be a plus 2. They are same thing. So differentiate. Power on top here, a to the front, 5 over 3. Differentiate x plus 2. 1. Write this entire question and you want from the power. 5 over 3 minus 1 give you 2 over 3. Now I still like to retain this entire thing here. It's a 0 because it's all a constant. So that's why I'm not putting it here. Differentiate x minus a here. What do I end up having here? 1. Then I cannot confidently plug in my what? My limit. Anyway, I see x, I just get a. 5 over 3 times 1 is what? 5 over 3. Then a enters. Solve it. No issue. Alright. Everybody, you are trying this number 7. Let me answer. Try number 7 and let me answer, please.
H tends to what? H tends to what?
H tends to 0. We are everybody try number 3 and then the number 7. Try number 7 and then the answer.
I'm not done.
So the answer cannot be 0.
It can't be 0.
Each end is 0. One. Answer is not even 1. Let me help you.
What's X?
X is just there. Let me help you. The answer is not even a number, sir. It's not undefined.
Minus 1 over 2.
No. It's not in decimal.
Infinity. Infinity.
How do you want to have infinity inside this place? Differentiate job. H is a constant, yes, definitely. Yes.
What about? Definitely.
X plus H.
1 over 1.
Then that means you see that if you differentiate here, it shouldn't work. Then take conjugate.
Also conjugate.
Rationalize. Because if you differentiate here, see, H is a constant. And if you differentiate the constant, what do you have? And I have something divided by 0. So rationalize.
Rationalize, okay.
Rationalize, and that's the answer. Rationalize and plug it in.
Also naturalize.
Yeah, never rationalize.
We know it.
Ah, no more.
Time is positive of this one.
So I don't understand. I don't know. I mean, I will not lie. I don't know. Maybe it's another English they used to use for me, but I don't. I don't understand.
Multiply up and down by the conjugate of up. That rationalize.
Conjugate.
Conjugate. Take that sign for minus plus.
This one.
Okay.
We did it previously before I started.
Okay. Multiply by the opposite. Ah.
Multiply up and down by the conjugate of the numerator.
Ó ti yé mi, ó ti yé mi.
The same thing, but that sign in between will change from minus to plus. All the signs in between the source will change. Sir? What's the answer? 1 over 2x squared. Yeah, yes. I mean, 1 over 2x, sorry. I mean, now.
Ara o mi ò mọ̀ o. Ayé máa sọ yes. Sá ẹ wo mi ò mọ̀ o. Ah, èwo ni yes. Eh?
X plus h minus square root of x. Square root of x plus h plus square root of x. Square root of x. 1 over x plus h plus square root of x. Then if you observe, numerator mix difference of 2 squared. If you as h tends to 0, square root of x plus h squared minus square root of x all squared all over h square root of x plus h plus square root of x. Now by the time you put the square, if it as h tends to 0, x plus h minus x h square root of x plus h plus square root of x. X cancel x. That repeats h tends to 0 plus h over h x plus h plus square root of x. H cancel h. You are left with limits as x tends to 0 1 over square root of what? X plus h plus square root of x. Not do your 0 here. 1 over square root of x plus 0 x. So it's not h, it's h. And by the time you have 1 over square root of x plus square root of x, 1 over what? Square root of x. That's the answer. But you don't get it.
If you say yes, I will punch you.
The last part of limits for your level actually. The last part of limit for your level is trigonometry limits. Trig limits. Trig limits. Trig.
Ẹ wo ara kan mi o.
Trig limits. Yeah, where's the calculator, please?
There's one in my pocket. Dogoni, if the calculator can do all this thing, is it possible?
They say calculator can do it, but I don't know. They say I can do it, I don't know. Rather than learning calculator, I learned the trick myself. So.
It's in a scam, Gary.
Attention, go next out. Show some amount.
Censé or no? Hello? One of these, please, Ejo.
Not you. Tinubu. Not you. Not you. Manu. Oh, but what like
You can use that when you are doing CBT. So that one is when you are having it. Or you are doing complex, doing analysis. You get my point. You are doing CBT. Now for the next section, which is trig limits. And that's where we are. The next section, which is trig limits. There are 72 questions here. And as usual, I know that the first one you picked, what do you call? You picked 7 out of 40. I did the mathematics about like 75% of what I did. And this time around, we are going to pick 13 out of 72. So as usual, I call everybody to random. And this time around, let nobody pressure you. Pick any number that comes directly to your mind. I'll get my point, please. The last border at that corner. Pick number 172. 72 itself. God bless you. Next, who should I call? My boy, you. You.
Number 7.
Number 7. Or 7 left. My boy. Go. 18. You will not. 37. The sister beside you, no big. 62. I love that. I will. Number 172. 19. I do this 62. 19. But I don't take a blue. I don't take a 21. God bless you. You. Yes, wait. Yeah, 172. 20.
Ah, lóbìnrin sí. Sems la wa. Na senior men. We have men and senior men. Seventy. I meet
Then, but I don't know yet. Big number. Yes. 65. God bless you.
82.
How many is that? Okay, Nico. Myself. Number 1. So now, please, every arrange your number. Jesus Christ. Arrange that number, please, from the highest to the lowest. Yeah. Arrange from the highest to the lowest. I mean, lowest to the highest. Sorry. Lowest to the highest.
The highest is the first part. One for me.
nothing for you.
Legacy, one for me.
Nothing for you. Ah.
Say it to the boy, Gary and the Thailand will never be reward.
Yeah, let's go. First one. What I want to do on the board might look like magic. Boys, I don't know what's okay. Anyway, go and push it back. Go and put your phone on silent, please. It's already 7 and we are still on the first topic. Don't worry.
Yeah, I need water.
You go fit mú gàrí. Ah. No, you have to. I want to eat. What is gàrí? I want to gàrí. When I bring something, I want to eat.
Whenever you have sign over your linear function.
Guys, listen, man.
Whenever you have sign over your linear function. Whenever you have sign over your linear function, I want to be over your linear function. Anytime you have sign over your linear function, hand over your linear function, form over your linear function, cosec over your linear. I just call 4 chief functions now. I repeat, sign over a linear, port over linear, hand over linear, and what's the last one?
Cosec
over linear.
Whatever you should do is just extract the coefficient of x in that form you have, and that is your answer. Extract the coefficient of x, and that's your answer. You have got triple. So which means that here, my answer is what? 4 over 6, and that's what?
2 over 3.
That's all. Closer. Next question, please. Question 7. Alright. Limit at x tends to 3 sin nx over sin nx. Now here, as I said, that trick only works when you are dealing with science. All of those 4 tricks that I call works for it. You are getting my point now. So what?
When they go anywhere.
Yes. Here, as I explained to you, since both of them is sign and tan, what I want to do will work. Just extract the coefficient. So the answer here is what?
M over N.
That's all. Please note, it only works for, how does it work? I said, either it works for sine, cos, tan, cosec, over linear, or any of those four divided by themselves.
What about cos?
Come out and next. Even because I will treat cos, provided the quick hit. Should I get my point? So there are two conditions. Condition number one, anytime you have any of those four strict conditions I call all over a linear, extract coefficient. Second one, anytime you have any of those four, dividing themselves, that is sine over tan or cos over cosec, any of those ones, extract their what? Coefficient. Next question, please.
What? You said 4. What about can you put that down?
Sine,
Sine, cos,
sine, cosec.
tan, cosec. What about can you?
Cos. That one doesn't work for it.
Cos. Don't even go.
Dika.
So this case here, you can write this stuff here, so that we can have some number of coefficients. Sine 1 over 4x, 1 over x. Both of them are linear. I have sine over linear. So let's go. That's what.
1 over 4.
1 over 4. Next one. And x all over 2 all over 3x. Right, so that you can have your linear problem. Yes, one over 4. Yes, that's always there. It's not always all the time in tree. But for these cases, you see stuff like that.
That's
I have a tan 1 over 2x, 1 over 3x. So what is my answer here? 1
1 over 2 over 3. That's 3 over 2.
1 over 6. Number 5, x. 20. Okay, finally we have 1. Limit as x tends to 0 of 1 minus cos x all over sine squared x. Now, the rule breaks here because by the time you observe it, I have a cos, and even the sign that I even have here is a what? Is a have a power. Now I want to do some stuff here. I can do this in about like 3 different methods. I can use L-Hospital because L-Hospital is such that if you see, for example here, if you plug in 0 here, what end up having here? 1 minus 0 is what? 1. 1 minus 1 is what? 0. Sine square 0 is the same thing as what? 0 now. So I can use L-Hospital rule. And what is L-Hospital rule? Whenever you have 0 over 0, is that not so? Now another way I can use this is very smart. I will take my time, provided you can remember trick. Even though you don't know trick, you can use L-Hospital rule. Not this point. But here I want to use trig. In trig, you know that sine squared x plus cos squared x
equals to 1.
Then for you to have sine squared x, they know 5 cos squared x to the other side. Which means that sine squared x 1 minus cos squared x. So if I write this entire thing here, that's going to be 1 minus cos x all over what? 1 minus cos squared x. Now if you look at this your denominator, I can write 1 as what? 1 square. Yes or no? Then I can now apply difference of 2 square to my denominator. Limit x tends to 0. 1 minus cos x all over
1 plus cos
1 minus cos x
1 plus cos x.
1 plus cos x. So what happens?
Cancel each other.
That's
1 over.
Limit x tends to 0 of what? 1 over 1 plus cos x. I know that if I put 0 inside here, I'm not going to put 0 again. My final answer is just what? 1 that's what 1 over 2. This is 1 way. L depends on how you want to differentiate sine squared. For that same question, whether you know how to differentiate, limit as x tends to 0, 1 minus cos x, 1 over sin square x. If I differentiate the numerator, what do I end up having? Minus sin x. 1 over. Differentiate sin x, which one to the front first? 2. Differentiate sin x plus x. Right, so which one remove 1? Sin x. Using this one here, we have sin x all over 2 plus x sin x. Sin cancel sin. We are left with 1 over plus x. Then putting your number back here. 1 over 2 times 1 over 2. As I said, provided you have to differentiate, can use this.
I refuse to be confused. No. Just leave this back. It's my.
1 minus cos 3x 1 over x squared. If you look at this one now, you observe the plugging zero will cause the problem. Look at, I mean now, let the L of the down. If you differentiate this minus, you are just cos 3x, what I have? Minus 3
sin x
1 over
2x.
2x. By the time you expand now, you have what? 3 sin 3x 1 over 2x. I can now apply that short what I told you. Now whenever you have x over linear, write out your coefficient. But do not forget this thing here also. So which means it's going to give what? 3
times
3 over 2. And that's what?
9 over 2.
Next one. 24. Now the next step is 0. 1 minus cos 4x. 1 minus cos 6x. Now, looking at it here, if you plug in your 0, where is it now? End up with our minus differentiate cos 4x minus 4 differentiate minus 6
Sin x.
then by simplify that limit x tends to 0 of what?
4 sin 4x over 6 sin 6x. 4 times 4, 6 times 6. 6 over 36. 1 over 2. 1 over 2. Guy, are you not right? Guy, are you not writing? It's like because I'm still having call you done. Hey, because are you not writing? How do you guys do with that? Let me see.
Brown.
I don't like passing.
No, really.
Oh, he knows what I mean.
No, really. I'm still looking the problem. See, Davis, the problem that not making me allowed to see. I'm still drinking it again.
Let's go. Login zero here will give us a lot of problems. Elevator. I'm making my time here because I know that mistakes there will be mistakes here. Differentiate. Bring it 0 is here. Will I agree? And let's see. Sec is the inverse of cos. So which means that cos 0 and sec 0 is the same thing.
Wow.
0 minus 0. I mean 1 minus 1 all over what? Sec is the inverse of cos. And sec 0 and cos 0 is equal to the same thing because cos 0 is 1. Definitely sec 0 is 1. So if I put 0 here, I will have 1 minus 1 all over 0 and that's 0 over 0. What do I do again? L'hopital. Now, for this l'hopital here, limit as x tends to 0. Take it easy now. I want to differentiate with sec squared x. I can write the answer down, but then you guys start questioning how can I say sec squared x, write it down. As sec x all squared. Two on top, one to the front. Differentiate sec x itself. That's sec x and x times, write your question back here. Sec x 2 minus 1 here, give me 1. I will get at this. By the time you multiply this one, you don't know the power of 1. To multiply this, it will give you what? Sec squared x and x. If I differentiate this, you have 2 sec squared x and x. I hope you know that if you get minus cos x, you have a plus minus all over what? X. Now looking at it again, try again. What is 0? Will I have l'hopital? Now because for example, tan 0 is 0. That's my point here. Tan 0 is 0. So 0 multiplied by anything that we have there will give me 0. Tan 0 here is also what? Also 0. So I have a 0 plus 0 to give me what? 0. Not giving 0 here, 6 times 0 also give me what? 0. And I have 0 over 0. What will I do again? L'hopital. So you keep using l'hopital until what you have are shifted away from what? 0 over 0. Now, moving to differentiate sec square x and x, I will just put up 2. Let's put up 2 differentiate. Limit x tends to 0. We have this 2 sec square x. If you differentiate tan x, what end up having?
Yes,
x plus tan x. If you differentiate 2 sec square x, first of all, write your 2 out. I think I just differentiated sec square. Give me this answer. So which means that if I differentiate sec square, what will I end up having?
2 sec square x tan x plus cos x plus cos x over 6
By the time you multiply and compare,
don't waste time, please. I go
sec 4x plus 4 tan square x sec square x plus cos x all over 6. Now, from here, I know that if I plug in 0, I will not have
1 over 6
because 4 0 give me 1. So let me just plug everything now. Let me show you how to do it. Plug in 0 here, I will have 1 plus 4. Tan square 0 is what? 0. 1 plus what is for 0 here? 1 all over 6. Then at the end of the day, what I end up having here? 2 plus 1 all over 6. 3 over 6 and that's what? 1 over 2. So that's the whole concept. Say, you use l'hopital. Anytime I use l'hopital, you continue using it until you get to what? To something that will shift away from what? And indeterminate form.
You can't solve it within 5 seconds.
Likely you are not able to see this kind of concept.
So can we just speak?
And you can speak. You know how to put up for you. And which I know that my people will must. I will say what this man said. What Gabriel said in the beginning. have something. Most of these answers, you have to check you. Like I said, option A0, option B1, option C half, option D2. You will know that everything that begins is money has always been regulated between 0, 1, 2, and half. So you will not know which one to pick when you solve. This one does happen to be like that in this case. So that everything that begins is money.
That's very sure.
Like the progression DSF. Only motion law. Like there's a way that I will see the answer. It was in this square, the answer will be 2. The 2 was near J1. Oh yeah now. Excuse me, I don't know that yet. Sir? Sir? That's the thing that only me say. I'm not going to ask. Yeah, the MTS, you know, my take cost of money in semester. And there's my just one. I did.
I didn't do
I do, they do so too. I did the MTS so too. What is it 3 level? MTS delayed, but this is 7 semester 300 level. 7. I know that.
Yeah, fair.
Go pay.
Fẹ́ gbá mi bẹ́ẹ̀ ojú.
Give me that blood. My phone off. That was in the blood. That was in the blood.
I heard that there is a current story going on. I don't know if that started. But they say it's a 12-hour story. 500.
Yes.
12-hour story, 500. They're currently holding at
FBN.
FBN. So, I'll be frank. Don't feel that I'm not saying it's not happening because number one, considering it's our current pace, I don't know, we might not even be able to finish anything that we're doing. MTS 201 is too much to finish in either 12 hours or 24 hours. Yes, it's too much. You can't finish it.
If you finish MTS.
You can't finish it. You can't just finish it. I'm saying this because if you have not started reading MTS before, and you just say that, okay, you want to use one night to cover it.
I have passed my boundary, sir.
Oh yeah, are we not writing?
Yeah, no. Yes, sir.
That I saw the plan, I just started listening to my mind. Okay, let's minus the tutor away. Which amongst you here can sit down to learn for 12 hours? Have a day manifa.
Me, even if I get it by myself, I go sleep.
Active. I was like, it's a plan of them. Grace, what's a plan? What's a body me bear, Matlo bear? I beg yes, it's more. Crown.
Try my best. I don't know where we can
Crown, we send I'm going there. Move the guy down.
I can't about that.
Eh?
I can't even get
Eh? What are you from?
I
Which video? I don't know.
Make I go.
Mo tún rán náà rọ.
Èwo ti pọ̀.
Àdúrà rẹ̀ kò sí. Kìtì ìgbà.
Tí wọ́n kọ́mọ̀ tó mo sanwó ni.
Wọ́n ní èsì tí wàá kọ́ fún èsì tó wọn.
Oya, Gabriel,
Tó bá lísítì kò wúlò fún mi.
I will have no problem. So end up with that was x minus was a. Was a and the constant. So if you get the constant equals to 0, you get was x minus sin x. You get x equal to 1. Minus a is the constant, so it goes to 0. Plug in your a inside here. And the final answer is what? Minus sin a. And that
Tí wọ́n kọ́ ti rí kọ́ọ̀sì méjì bẹ̀. Tí wọ́n ti rí kọ́ọ̀sì bẹ̀, àwọn kì í sáìn ní ánsà. Hey. Those vibe Tutor now. Sorry.
Sir, please continue, sir. Continue your back bench. Hello, listen now.
I'm not I need you. Seriously. You dey go now. What did I do again? You dey blog videos. In a live video shift. They go. Stand up. How long will you do this?
I differentiated, yes.
I mean, no official. So this second one, I just signed it was made.
No.
I will charge you times 5. This can calm down.
Mo pé iná wà bí mi lè ká wá Ọlọ́run. Ó tún wáyé tàbí lẹ́gbẹ̀ẹ́ sọ pé ká lọ tí kò ní náà tọ́.
One plus Gabriel.
Take now.
That's got 1/3.
What I have? 6, what I have?
Minus sign
They won't let me know.
minus sign
Where's the let's accept your comment.
one minus
I guess it was it.
yes, one.
Yes, sir.
Guy. One over two.
I'm going to pay more to him. You are paying more.
How many? Be 10 for.
People that are you going to pay more apart from what you have paid? Malọ ta ní ìsìn ẹ máa rí.
You need like send us anything. All these things. I know you want to say you want to settle down. Sorry.
They don't move our fast train. What's moving number 1, my move number 2, my move number 3, my move number 4. How this? Okay, sorry. So
Legacy of FUTA.
Legacy by Gabriel.
What about?
Not limited to FUTA, beg. Not limited.
Before you go outside,
No.
A plus. Minus 1. This is a good one.
Okay.
let me jump in. Look, you want to be close.
Minus 2A. Minus A minus 2. Yes, A minus 1.
Good job, good job.
What's it?
Hey, sorry.
What's it gbé mi débẹ̀?
Yes, it's true.
Ìwé mọ́.
Why is it?
Mi ò ríran ọlọ.
Ti bọ́jú ẹ.
I swear they see clearly like this, Aji. You can't blame me na Gary cause am.
Love to the body, put it on charge.
Just compare to quadratic combinability, substitute and rely. They can put in your value inside. Don't happy about that. I'm done with it.
Make I pay that. You go. Yeah, I can't.